Hello, you're right. So we finished the topic on energy, and what we are going to do today is we're going to start to look at how we actually work scientifically. So how do we work through the scientific method? You need to know about some of the communication and issues created by science. You need to know about risk during practical experiments, how you would go about designing investigation, how you would collect data and processing that data in things like graphs, what the data means, conclusions, and also things such as transferring between units. Okay, now all of this is quite tricky. Um, so we're going to basically be doing this over the remaining lessons of the year. So that will be approximately be sort of 6, 7 lessons. Okay. However, the first thing we need to do is we are going to quickly go through the answers to the test. So uh, we've got the test here. Okay, and so what I'll do is I'll start bringing up the answers and we will go through that. So um, grab your answers from the end of unit test from last half term and we will go through this now. Okay, so welcome back. So the first thing to do was you had to pick the correct word from the box to go in the space. So coal is burned to heat water in a furnace. Okay, that generates steam. Steam then drives a turbine, and a turbine turns a generator. Okay, so it's furnace and generator that you wanted. So 1 mark for each correct answer. The second question was this one. The diagram shows the energy transformation in a coal burning power station. So this is the energy going in from the coal. This is the energy being transferred to electrical power or electrical energy. And this is the energy which is wasted as, say, heat, which is transferred to the surrounding. So it says, calculate the efficiency of the power station and write down the equation you'd use. Then clearly show how you worked out your answer. So the answer was 0.3 or 30%. Okay, now how would you come to an answer like that? Basically, you do the useful energy divided by the total energy. So you actually needed to physically count these. So the total energy going in was, well, each of these has 1, 2, 3, 4, 5 squares. Okay, so you could do 5, 10, 15, and then 20. And then the useful energy was also the electrical energy. So, well, that's 1 square. And then there's an extra layer there. So that's 6. So 1, 2, 3, 4, 5, 6. You actually have to physically count them. So it'd be 6 divided by 20, which gives you 0.3. And then to get it to 30%, times it by 100. So useful energy divided by total energy gives you the efficiency. And that would be there. Next one, draw a ring around the correct answer to complete the following sentence. If fewer coal-burning power stations are used to generate electricity, the amount of carbon dioxide emitted to the atmosphere will decrease. 1 mark for that. And just in case you weren't sure, there it is. Some type of power station generate electricity by burning a biofuel. Give one example of a biofuel. Now that can be any fuel which is basically made from biological means like wood, because wood grows from trees. Okay, alcohol, ethanol, anything like that. So some of the examples that they give are wood, ethanol, straw, anything like that that comes from something that perhaps you grow is a biofuel. Nuclear power stations generate electricity without burning a fuel. Name the process by which nuclear power station provides energy needed to generate electricity. It is nuclear fission. Okay, nuclear fission. It's that word there, fission, that they were after, and that gets you 1 mark. Nuclear on its own doesn't. A nuclear reaction doesn't get you anything. It's fission that they want. Okay, so first question was out of 7 marks. So give yourself a score out of 7 for that, please. Question 2. The diagram below shows an experiment where a pendulum swings backwards and forwards. Pendulum is a small, heavy weight suspended by a light string. Okay, so there it was. You've got the pendulum swinging back and forth there. In which position, A, B, or C, does the pendulum have the least potential energy? Now remember, potential is gravitational potential. And for it to have gravitational potential, it needs to be lifted up. So therefore, where it has the least potential energy is where it's at its lowest position, which would be there, which would be point B. And again, just to confirm, it would be B. Now the next one, in which position A, B, or C does the pendulum have the greatest kinetic energy? Basically, where is it moving fastest? Okay, so think about how energy transfers. Okay, as a pendulum swings backwards and forwards, kinetic energy and gravitational potential energy constantly transfer. So here, up here, it's got the most gravitational potential energy. The point where all of that transfers to kinetic energy is there, point B. So once again, it's B, okay? Because it's not potential energy now, it's all kinetic energy. After a few minutes, the size of the swings becomes smaller. Explain why this happens. Right, so some of the energy, that potential, constant switching between gravitational potential and kinetic energy, some of that energy is transferred to the surroundings. As the ball or pendulum moves through the air, it transfers that to some of the particles of the air. So a way you could do that is energy is lost because it's doing work against air resistance or friction. So as I said, as the pendulum swings, it pushes through the air and it transfers some of its energy to the air. So with every swing, it will just swing slightly less. Okay, so energy is lost because energy is being transferred to the surroundings. Right, B, if the experiment were repeated on the moon, the pendulum would swing more slowly. Suggest a reason for this. Right, what do we know about the moon? Well, very simply, the moon has less gravity, not zero, but it has less gravity. So there is less energy for restoring forces. Okay, so there's basically less gravity, so there's less potential energy that you could get. Okay. Okay, question 3. A forklift truck was used to stack boxes into a trailer. It lifted a box weighing 1,900 newtons through 4.5 meters. Calculate the work done, show your workings. So the equation for work done is force times distance. So you've got those. So basically you just need to do 1,900 times 4.5, which gives you an answer of 8,550. Okay, now here's the key thing. 8,550 would only get you the 2 marks. Okay, oh no, it wouldn't actually, it would get you all 3 marks. So yeah, the calculation gets you 2 marks, and the right answer of 8,550 gets you your final mark. And remember, work done is a measure of the energy transferred, so it would be joules. The diagram shows a side view of a double glazed window. So you've got inside the house, you've then got glass, air, and then another panel of glass, and then cool air outside. Use each of the terms in the box to explain how heat is lost from inside the house. Conduction, convection, radiation. Okay, so for this, heat is conducted through the glass. Okay, remember glass is a solid and heat conducts through solids. Heat passes through the glass and air by radiation, and heat crosses the air gap by convection. Okay, 1, 2, 3 marks. So if you mentioned that, essentially what's going on is heat will pass by conduction. Remember, the particles will be very close together in glass because it's a solid, so it'll pass through there. Then the air will circulate by convection in the gap, and then eventually that energy will transfer to this one, and the energy will convect through as a solid through here. But as radiation, it can go zoom straight through. Okay, so energy can be lost that way. Okay, so 3 marks if you mentioned those. Beside heat, state one other form of energy that passes through double glazed windows. Okay, you had a couple of answers here you could have had. You could have had light, X-rays, radio. Sound you could have had Okay, basically any of the electromagnetic waves, if you know what any of those are yet, but you also could have had sound. Okay, so on to the next one. Explain why plastic foam cavity wall insulation cuts down energy transfer between warm inner walls and cooler outer walls. Okay, so you've got a little bit of space to give your 2-mark answer here. The way it works is like this. You could have had any of these actually. It cuts down on convection currents because think about it. If you fill it with foam, the air is not going to be able to move. It's not going to be able to convect. So stops air moving. Have air pockets. Foam is a poor conductor. Would also be included. Air pockets trapped air, so stops the air from moving. Do not accept stops heat. Okay, so we can't have that. Stops heat from moving because it doesn't. It just slows it. Air in the foam is a good insulator, would get you a mark. So there's a few answers there that you could definitely have. Okay. And then question D. When it rains, the walls and windows of a house get wet. Explain how the drying process can increase the cooling of a house. Okay, so you could have had the evaporation of the water, okay, takes energy from the house. Okay, so you need to say the evaporation, 1 mark, takes energy away from the house, 2 marks. Okay, so there it is. Okay, question 5 is another Sankey diagram. So in a traditional power station, 30% of the energy input is usefully transferred to electricity, the rest is wasted as heat. The diagram shows the energy transfer in a combined heat and power station. So there's your input energy, could be coal, oil, gas, whatever. Half of it used to heat local shops, factories and homes, generate electricity, and then 20% is wasted as heat. Explain why replacing traditional power stations by combined heat and power stations may be beneficial to the environment. So you've got space there for a couple of marks. So things you could have had. This basic understanding that if you're using the heat from a power station, you don't need to then use heat to do something else. Okay? Less heat energy is wasted, or reduced demand for fuels to heat homes because you're getting that energy from the power station. Okay? Re-quoting figures gets no credits. You can't just basically say what's out there before. Okay? The second mark, so therefore there's the idea of less pollution. Do not accept no pollution. So if you said it causes no pollution, that's not true because it does. Less fossil fuels are being burnt in power station, so it will reduce global warming, reduce the greenhouse effect, or fewer power stations required or electricity needed to be produced because, think about it, you don't need to use the heat, you don't need to burn fuel to generate heat anymore because you can just use the waste heat from the power station. That's your second mark there. Right, on to question 6. So you've got a diagram of a house. The drawing shows part of a house where it is possible to reduce the amount of energy lost. Okay, so you've got all these different parts, walls, roof, boiler, hot water tank, and they're all labelled up there. Give one way in which the amount of energy lost could be reduced from each of the following parts of the house. Right, 1, 2, and 4. So walls, roof, and the hot water tank. So what could you do with those? Okay. 5 is the windows and 7 is the door. Okay, so your ideas would be some kind of insulation. So if you gave an example like fiberglass or loft insulation, that would be fine to protect the walls, the roof and the tank. Double glazing or curtains for the windows, draft excluder, double glaze it, close fitting door for the door. Energy consumption can be reduced by using a more efficient boiler or more efficient light bulbs. What is meant by more efficient light bulb? So what it actually means by that is transfers more useful energy. So say for example with a light bulb, more energy is transferred as light, or a higher proportion is transferred as light than say as heat. Okay, or converts more energy into light or less into heat, or less energy is wasted. So that was worth 4 marks, question 6. Question 7. Much of the world's electricity is generated in power stations that burn fossil fuels. The bar chart shows startup times for these types of fossil fuel power station. So coal obviously takes 3 days to get going. Gas, just about half a day, maybe, something like that, a few hours. And the oil takes a couple of days to get going. Which of these power stations take the longest to start generating electricity? Obviously, 1 mark would be the coal. Which of the 2 following statements are good reasons for using fossil fuels to generate electricity? Put a tick in the box next to your choice. So there are your choices, and your answers were: fossil fuels can be used to generate electricity at any time. A few large power stations can generate electricity for millions of homes. So those are your 2 boxes that you should have ticked. Right, electricity can be generated using energy from the wind. Why does a wind generator not produce carbon dioxide? Essentially, how you word it, no fuel is burned. So you can put anything along those lines. No fuel is burned, so it doesn't produce any carbon dioxide. Which form of energy is transferred from wind to generate electricity? It is kinetic energy. How many people say that many people say that wind-powered station generators are a good idea because when the wind blows, they generate electricity, they produce no pollution, they generate electricity cheaply. But not everyone wants more wind-powered generators to be built. We've got some protesters there. What reasons may be given by the people who think that wind power generator is not a good idea? Okay, so these would be some of the possible ideas. They cause noise pollution. Maybe they're not very nice to look at. Visual pollution. Okay. They need concrete for bases, which, new roads and infrastructure are going to be needed to actually build them. May interfere with TV, radio, mobile, possibly phone signals. Dangerous to birds. They don't generate electricity all of the time. On a calm day, they're not going to generate any electricity. You need a lot of them. They don't generate very much electricity even when they're working well. So you'd need a lot of them. For example, you'd need 1,500 wind turbines to generate the same electricity as 1 nuclear power station. They have a high initial capital cost. That means they're expensive to build. Okay, they're not expensive once they're built. They're free once they're up and running, but they are expensive to actually build, and potentially could reduce house prices in the area. So basically, any of those would get you your 2 marks. So that's the end of question 7. Right, now on to question 8. Oh. Winds and tides are renewable energy sources that are used to generate electricity. Complete the sentence by putting a tick in the box. So the wind is an unreliable energy source. We don't know when the wind is going to blow, so we can't constantly rely on it. The tides are a predictable energy source. We know when the tides are going to come in and out. We've studied them. We know exactly when they are. They're not constant, they're not always in and out, but we do know when they are. Okay, so that's why they're predictable. If wood is to be used as a renewable energy source, what must be done each time a tree is chopped down? Okay, so if it's renewable, what must you need to do? So you've got to plant a new tree for every one you chop down, or words to that effect. And C, in the UK, electricity is generated using renewable and non-renewable energy sources. The graph shows the percentage of electricity generated using renewable energy between 1990 and 2005. So as you can see, the amount of electricity generated from renewables has been going up pretty steadily since about 1996. Okay, complete the following sentence by drawing a ring around the correct box. In 2015, the percentage of electricity generated using renewable sources is most, right, so 2015 is likely to be greater than 4%, equal to 4%, less than 4%. Now look, there's 4. Well, there we are in 2005. So by 2015, what would it be? Well, it would probably be greater than 4%. Right, and then finally, question 9. This is the one where you have to do a little bit of maths. So, picture shows one type of solar water heater. Water from the tank is slowly pumped through copper pipes inside a solar panel where water is heated by energy from the sun. And there's our diagram. Explain why the copper pipes inside the solar panels are painted black. Okay, so, oops, I didn't mean to see that. So, question 9, black is a good absorber of the radiation or the sun's energy and thereful be a faster transfer of energy. Basically, this idea that dark colours, so black, absorbs heat, so will transfer the energy really quickly. Okay, that's what you need to say. Right, each day, the average European family uses 100 kilograms of water. To kill bacteria, the water going into the tank at 20 degrees must be heated to 60 degrees. Calculate the energy needed to increase the temperature of 100 kilograms of water by 40 degrees. The specific heat capacity of water is 4,200 joules per kilogram degree centigrade. Write down the equation you would use. Right, so for this one, what you need to think about is, how do I work out the energy? So it's mass times temperature increase times specific heat capacity. Now, we know the mass, it's 100 kilograms, 100 kilograms of water. The temperature, and from 20 up to 60, so obviously that was an increase of 40, and the specific heat capacity is 4,200. So you simply multiply those together to come out with your final answer, and your final answer would be, so 100 times 4,200 times 40 is 168 followed by 5 zeros. So that's 16,800,000 joules for your answer. And there it is. Okay, so what you need to do now is tot up your final mark. So I'll just quickly work out what that is. Okay, so the total marks are out of 44. So if you can please send me over your scores. You can either put them in assignments or email me, or if you want to put them on the chat, that's fine. But send me your marks out of 44, please. Okay, so I'll give you a few minutes just to do that now. So just pause it and you can do that now.
Okay, Year 8. So this is what we are going to be working on over the next few lessons, and there are many branches to this. So the first thing is scientific method. So this is one of the key skills you're tested on in all papers, biology, chemistry, and physics. And when you get your revision guide at the beginning of next year, this is at the front of all of them, and it actually is pretty much the same throughout them. And it's all about working through logically. Now, in assignments, there is a video link. What I want you to do is pause this video and then click on that video and watch that. And then what you are going to do is you are going to apply your own scientific method. Okay, so I've done as a flowchart. So I've done the first sort of 3 steps. So you make an observation on something you don't understand, and then you come up with a hypothesis, so a possible explanation. And then I want you to apply the other steps. So this could be something, for example, that you observe around your home. So you could make an observation. It could be something as simple as pick up a pencil and drop it. Why does the pencil fall? Okay, you observe a pencil falling. Why? Come up with a possible reason. So what could be a possible explanation for that? And then apply some of the other steps. Now, obviously, conducting an experiment might be quite difficult, but something simple like dropping a pencil, you could drop a pencil and then a pen and then maybe a book and see if you get similar or same results. So that would be something that you could do. And then explain how you would write your results up. And if you want, you can put a little bit about those in. So what I want you to do is pause the video now and watch the link in the clip, and then just do a simple flowchart with a simple observation about something around your home. Now, when you do this, this should take you no more than about 10-15 minutes to draw this up, because this is just supposed to be something simple. It's a little bit of fun doing something this I can see your home, but applying all 6 steps of the scientific method. Okay, so think about what those steps are. So pause the video, watch the video in assignments, then come back and do a flow chart, but no more than 2 or 3 sentences in each box of the flow chart. Okay, otherwise you're going to be here all day. Really simple, something that you've noticed around your home and how you would come to a conclusion of a working theory. Okay, so pause that and do that now, please. Okay, so there is one key method, sorry, thing I want you to take away from the lesson today. Okay, what is the main takeaway? And that is this. Okay, a scientific theory is only as good as the evidence that supports it, and scientific theories need to change based on the evidence that we have. So, for example, it's like being a member of a jury. You wouldn't convict a person if all the evidence suggested they were innocent, even if you didn't like them, even if you knew maybe that they'd committed other crimes. If you're only trying them for that particular crime, you wouldn't commit them, you wouldn't convict them based on the evidence if they didn't do it. And science works a bit like that. We follow the evidence, and if the evidence doesn't fit our theory, then we have to change it. And we have to allow ourselves to be open to criticism by other scientists. They have to be able to look at our work and say, actually, mate, you've made a mistake here, or maybe your method would be better if you did it this way, or you've only done this with a few people, and that's probably not enough for you to get reliable results. So there's lots of reasons why science is so rigorous. Okay, and that's one of the reasons it's a really powerful tool, this scientific method, this way of getting to the truth. Okay, and that's what the scientific method basically is. It's this way, this method. How do you get to the truth? And that is what I want you to understand. And you can apply it to all parts of your life. Okay, you can not only apply it to actual science, actual theories, but also, you know, in everyday life, you make an observation. Why is that woman walking down the street wearing a strange hat? Okay, come up with a hypothesis. They might be having a complete breakdown. What is the other evidence? Maybe they're doing it for a charity walk. Okay, is that actually something you can formulate, or things like that? So there's lots of ways. It's a really powerful tool. It's a method of thinking, and that is what I want you to think about. So today's lesson, you should have got the answers to your test. You should have watched the video about the scientific method, and you should have completed your step-by-step process for something just around your home or in your garden or wherever. Okay, and just 2 or 3 sentences in each box. Okay, what have you noticed? What are the 6 steps to the scientific method? Okay, so what you need to do is just maybe snap a picture on your phone and upload that to assignments at the end of the day. Okay, thanks everyone, and I will see you next week, I believe. Yes, see you next week. Thanks. Bye. Oh, and of course, I'll be online to answer your questions.